Okay. Hello, hello. This is Aaron from Solace, back at you with another weekly office hours talking about all things Solace. Today is August the 18th, 2020, 12 noon here in Singapore. Hello, happy days to wherever you are, wherever you're tuning in from, or whenever you watch this at some point. For the next hour, I'm going to be talking about all things Solace. Going to be checking out our Solace community for some Q&A. I might do a little coding, some stuff I'm working on, and talk about some upcoming events and all that kind of stuff. So fingers crossed there are some people out there. Come say hello. Come join us on the Twitch chat. Tweet me at Solace Devs. I'll try and keep an eye on that, although I don't usually hit refresh all that often. And yeah, I'll be checking out the old Solace community. So what do you got? Hey, all right. Ran. I don't even know how to pronounce this name. Welcome from Solace community. Good to have you on the chat. Alamaran. Is that okay? I don't know. If you can spell it phonetically, that'd be awesome. Welcome to the office hours. We're gonna do today. We'll do some Q&A with your questions. So we got a joiner from our Solace community who's asked a bunch of questions, and why don't we talk about it? So let's get into that. Hopefully that's it. Nicely done, Almaran. Okay, I hope that's good. All right. Well, I'm Aaron. Hi. How do you do? Let's get into this. So first thing, just before we get started, just talk about some upcoming events. No Solace specific ones this week. Usually on Wednesday we do our developer virtual workshop or a live stream, a live code stream. None of that. But tomorrow I'm actually going to be doing a talk at this API Days conference. It's supposed to be API Days Singapore. Obviously, it's not actually happening in person, so it is going to be. It's a virtual conference, and yeah, I'm giving a workshop in the afternoon on APIs. And the evolution of APIs to event-driven. I haven't really finished it yet, so I'm going to be working on that later today. Events and the async API specification with Solace. So that's going to be my talk. We got a few other people talking. Smit Puri, who's our global head of technology, is going to be speaking as well at a roundtable. And my old boss, Phil, is going to be talking on Thursday as well. So more on the on the finance side and how Solace and event-driven technologies help with that. So I'm pretty sure it's free to join. I actually don't know. Just Google API Days Solace if you're out there and you want to find out about it. I think my thing's going to be recorded, so if you don't manage to catch it, you can tune in later. Yeah, let me hit refresh on Twitter here, just make sure I'm not missing anything. Like I said, I try and keep an eye on it, but I don't always. Bum, 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 bum. Yeah, all right, cool. All right. So, yeah. Oh, what's going on? Damn it. There we go. Okay, so that is going to be on Wednesday. What's coming up after that? I don't know. Let's check really quickly. Solace.com/events, where to go for all of the Solace events that are coming up. Ones that we're hosting as well as ones that our partners are hosting. Got my coffee here, my pivotal mug. Yeah, so this is the API one. The Kafka Summit. Yes, that's next week. So competitor, frenemy. Kafka is another technology out there that does a lot of event-driven streaming platform. We run into it a lot at various customer sites. We're often contrasted to them. We are complementary. We do similar things, but we do things differently. And we're going to be doing a couple big reveals there. Some stuff that we've done specifically for Kafka integration with Solace. Yeah, we're going to be talking about that. So I believe it's hosted by Confluent. I'm pretty sure the actual Kafka Summit is. And I think it's free as well. So this is something else if you want to sign up. If you want to learn about event-driven stuff, this is going to be a massive, massive conference, right? And this is not Solace at all. This is actually probably one of our bigger open source competitors. But this is going to be an amazing conference. There's going to be lots of good developer stuff there, probably a lot of good architecture stuff just in general on how to build event-driven systems. A lot of that stuff will apply to Solace. Not all of it. You know, Kafka does event-driven in a different kind of way. Kafka does pub/sub in a very different kind of way than Solace does. It's a lot more kind of database-centric way of doing pub/sub, whereas Solace is more kind of network-oriented pub/sub, so different approaches. But yeah, that's next week. So if you want to check that out, do so. I think it's in during California time, so it might make it a bit tough for APAC people. I might have to stay up late to catch some of those things. Anyway, that's it for now. There's gonna be some stuff back in September. So yeah, Solace is kind of paused on our kind of our usual developer Wednesday workshops for the time being. I think until about early or mid-September. Part of that's just vacation, you know, schedules in Ottawa and Canada, in the US and in Europe. Everybody seems to be on vacation in April. Okay, so that's that. If you're out there, come say hello, come say hi. We got Almiran and Aaron online having a chat. Check out our Solace community. This is the one-stop shop for all things Q&A and finding out what's going on in Solace. We kind of post up various events that are happening here. Oh yeah, the events are on the sidebar as well. Check that out. I post about demos and things that I'm working on. We do polls. We have fun. Solace.community. What other really good places? Solace.dev. This is kind of your starting page if you're a developer on Solace. You know, the Solace.com website is really geared for, I don't know, a little bit higher level stuff, right? It does get into the product, but you have to hunt a little bit. You know, the first time you land on Solace.com, there's a lot of marketing talk, I find. So Solace.dev is kind of our developer landing page where it gets straight into the APIs and some code. Great place to start looking. So if you're new to Solace, check out Solace.dev. Check out our documents. Check out our GitHub pages. And yeah, let's take a look here. Hey, so Almiran, welcome. If you got a particular question you want to talk about, or just you know, banter around, and you're out there and you're listening, you know, post it up. I'm just going to take a browse here and kind of I haven't actually been on the site in a little while, so I'm just going to kind of refresh myself here and see if there's anything that looks good. Spring Cloud Stream, I'll leave that for Mark. Reuse messages without calling reset. Oh, brand new one, eh? August 17th. What was that? That was yesterday. All right. Let's do this one. So Almiran's a pretty new user and has asked some pretty detailed, deep questions. I'm curious. Are you new to Solace, or have you used Solace before? You know, at a customer site or something? Because I've been at Solace for nine plus years, and you know, I haven't spent all that time coding with it, you know, but you push my knowledge for things. We have to go and get some R&D people to take a look at some of your questions. So let me know if you're out there still listening. All right, so is it safe to reuse messages without calling reset? So in our SMF APIs, so JCSMP for Java, CCSMP for C, CSMP for C# for .NET. Our SMF APIs have a message reset functionality, which allows a message to be reused. It essentially clears kind of the payload and clears various fields from it so you can use it. So let's take a look. Read here. So suppose I have a publisher class which encapsulates the details of blah blah blah. Given iMessage properties. Oh, right. We're using in my organization, slightly different pattern from what you're probably used to. Okay. Event carried state transfer. Yeah. Okay. A lot of different topics, right? Okay, that's interesting. Yeah. So in terms of how people use Solace or pub/sub or you know, just messaging in general, it kind of comes down to there's different patterns, right? There's kind of using it as a signaling mechanism to indicate that something has changed, you know, very lightweight, very small messages, you know, or carrying, you know, very small messages carrying sensor data versus kind of hypertext enabled messages, you know, it's still a very lightweight message, but it has all the links to kind of like find where to go and find all this information. You know, with a kind of a signaling based mechanism, you then probably have to go and do some query, some request reply to some backend database or some service to find out what actually changed. Versus carrying all of the state in the payload, which allows you, you know, to not have to go and query some additional service to find out what actually has changed, right? So, you know, a credit card transaction, for example, could have all of the details and information about that particular transaction inside the message. Obviously, you'd want to use encryption and other things so that people can't just snoop on that. But yeah, carrying the entire state inside the payload, it's not uncommon. You know, and sometimes it's striking a balance, right? Sometimes it's kind of going between putting too much data in there versus not enough, putting enough in there for 99% of people, and for the rest that don't, they have to go and query some additional service. It's all about balance, trade-offs between bandwidth and message rates and processing power and kind of access rights, you know? Sometimes you might have to publish multiple versions of the message with different kind of, you know, whatever people are authorized to see, perhaps on different VPNs. Different users have different ACLs, which kind of level of detail they're allowed to subscribe on. Back in the old days, Solace actually used to be content routing. So currently, you know, the product has been topic routing for years, but back in the early days when we started shipping product in 2005, we were actually a content routing broker that looked at XML payloads. And actually in the hardware appliance, we had an XML style sheet transform firmware card, PCIe card, that could do style sheet transforms on messages, basically in hardware. So you could kind of specify, you know, if you had a very lightweight consumer like a phone, you know, it could give you a very stripped down version of that XML document versus if you had a, you know, a bigger maybe database type application, it would want the full dump. You could have your style sheet not really affected very much. Pretty cool stuff based on your subscription. So basically the different types of subscribers would have different style sheet transforms built into it, and the broker would actually do it itself. Very cool stuff, but not that many people bought it. So we ended up discontinuing that probably about 8 years ago. But anyway, I'm rambling on here. Okay, let's talk about this. In Solace, I've seen advice that messages be reused. Yes. Is it safe to maintain a single instance of iMessage and only change blah, 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 blah? Okay. To be perfectly honest, I don't know actually the answer to this. You know, I don't know the API guts well enough to know specifically. Although I can tell you that years ago I was working with a customer working with the C API. Now the C# API, which I'm assuming you're using, judging by the nomenclature you're using here, the C# API is just a wrapper around the C API. So anything you can do with C#, well, most of the things you can do with C translate to C#. And I wrote an application that was a C application, and it was using our IPC capability. So we have a special add-on to the API, which allows you to do shared memory transfer. So actually doing pub/sub between processes on the same host, or using TCP, direct TCP socket without going through the broker. It's kind of a special add-on that a customer would have to buy to the. It allows C and C# to be used kind of without the broker, which is lower latency, you know, if you're looking at super low latency applications, but obviously it's now a point-to-point connection. Anyway, it doesn't really matter. We have an IPC capability in the C and C# API. And this trading platform that I was working on, basically we used an IPC publish, and then without calling reset, I called send on the message again to publish it to the broker. So I actually published the same message, the exact same message twice, just on 2 different sessions. So you know, so I had in my C application, I had an IPC session, and I had the regular kind of broker session, the normal one. And yeah, I would create a message and I would call send on it twice before calling reset. And that seemed to work. Didn't explode. So you know, if that's an indication that you can actually use a message multiple times, seemed to work. But this is a great question, and I know somebody in R&D that can probably give a really good answer on this, just to make sure. I'm a Java guy, so I know the Java API a little bit more. God, you know what? I don't even know about reset. It's definitely better, higher performance to not create new messages every time. As you get into more performance-oriented situations, yeah, I basically used to keep a message pool kind of available, kind of a short linked list essentially, and I would pull things off of that. Probably even an array would probably be even a smarter idea. But yeah, I basically had a collection of messages that I would just use and reset. When I'm done with it, I'll just stick it back in the pool, and I would kind of pull from there rather than creating new messages every time. I kind of assume it's the same with C and .NET. But yeah, hopefully someone smarter than me who knows this code really well will take a look. I think it's okay. Plans to use create videos. Yeah, it is. It is kind of rambling. Well, I gotta use up the whole hour, right? I do much more informative, shorter videos on YouTube. So check out our Solace YouTube channel. I got more point-specific stuff there. I probably should think of what I'm going to say and probably make it a little bit less, more brief. But no, this is meant to just be kind of a rambly kind of discussion about things. So dude, point noted. On this question, it really comes down to when things like sequence numbers are sent in the message property. Okay, so sequence number. Sequence number, are you talking about application sequence number or the sequence number that the API sets? So the API will set a sequence number once it has been published. Yeah, I don't know. It's not like the application message ID. Okay, hold on. Yeah, I can't say for certain in the C# API. I don't know. I'm pretty sure in Java and JCSMP it does copy the message contents into the socket, and you don't have to worry about reset if you just want to try and reuse the message. What's wrong with calling reset? Is it that you're finding that you were just resetting all the same stuff? Resetting, like putting all the same properties back into the message. More for code brevity than performance, eh? Yeah. I don't know. Has it exploded on you? I'm sure you've tried it, right? The API generated one, yeah. The API generated one is really only used internally within the API, and just on the send side, it doesn't get passed through the broker. It's used for kind of guaranteed messaging and kind of a little bit of state that's maintained in the API. People see, when they do message.dump on the consumer side, they see the sequence number, and with their logging enabled on the publisher side, they also see a sequence number when things are getting published. These are completely unrelated, and they cannot be, let's say, trusted or depended on. If you have an HA failover, the APIs might start renumbering things. If an application depends on sequence numbers in the messages, it should be up to the application to actually put them in there, right? Things like the application message ID, stuff like that, like application-owned fields. Don't trust the ones from the API specifically. So. Same topic Saturday because I haven't run yet. Well, I think it'll be okay. It's a brand new question, so hopefully someone from the internal R&D team might take a look at this. I have pinged one or two people internally to take a look at some of your questions. So like I said, I haven't been back on here in about a week, so I'm kind of a little bit behind. What's this one? Let's go find some more questions from Amran. Yes, accepted answer. Well done. Is this mine? Oh, this is my big, long, rambling one. Yeah, so I type like I talk, just rambling on. Different ways of handling it all comes down to basically what do you, the application, want to do. And like I said, usually that you're getting NACKs, I mean, unless something's wrong in the configuration of the broker, like you forgot to make a queue, or you forgot to enable some subscription, or something's wrong, or there's an ACL block. 9 times out of 10, it's not one of those issues, and it's usually a transient issue, like the queue is full temporarily, hopefully temporarily, right? So yeah, that's typically in a guaranteed messaging publishing application. You usually back off and kind of wait a little bit. So I actually haven't read what your follow-up answer is, and this is going to, I don't want to sit here online and just read it for 2. It's going to be boring for people watching me. Yeah, retry it for a while with the back off. Yeah. Yeah, good. So in terms of blocking the published thread, yeah. So I mean the C# API is, you know, by default, just, well, the way it is it's asynchronous already, right? So when you call send, it's not blocking. It's until you get that callback on a different thread. So I guess wrapping it in some bit of extra mechanics, yeah, that waiting for that correlation key makes it easier to yeah, I wish I was a C# guy. I could give you some better answers here. Rejection handling topic would be great. Conference talk. God, got a whole conference talk on that? No. But YouTube video, yeah, it should be. It's not so it's not a Solace specific, yeah, you're right, you know? I mean, so there are different ways of handling it in different brokers. I've seen some RabbitMQ code that doesn't have, more on the consumer side. So I was looking at it was Spring Cloud Stream's kind of binder code, and it was comparing how Solace handles consumer failures versus Rabbit. And in Solace, on the consumer side, there's things like, you know, there's redelivery counts, there's redelivery flags, you know, so if a consumer takes a message and fails, either it loses its network connection, or it throws in an unaccepted, like a runtime exception trying to parse the message and disconnects from its queue, you know, reads a message from the queue, that message will get put back on the queue and then sent to the next available consumer, right? So, you know, if there's a standby consumer, if it's an exclusive queue and there's a standby consumer, then, you know, you know, the next guy will get it. And that there's a redelivery flag that is going to be set on the next message to kind of give a clue to the next guy that you know, this message has already been sent. No acknowledgement was ever received, so we're sending it again. And you can configure your queues so that, you know, it counts how many of these redeliveries are made. And, you know, after like 10 times, you can kind of assume maybe it's a poison message, and you can move it into a dead message queue, right? You can have the broker just move it off to the side. Apparently, looking through the Spring Cloud Stream's Rabbit binder, it was handling all of that within the API space, within the application space. Like if the application received a message, tried to process it, and something went wrong, rather than kind of put it back to the broker, essentially kind of like a NACK, put it back onto the broker queue, it actually republished a new message to a different queue, kind of to an error handling queue. It said, okay, I don't know what to do with this message. I'm gonna get rid of it. So that could work in, you know, maybe when you have a poisoned message. That could be not great if, you know, maybe the particular version of the app that took it is old, and maybe the new version that you just rolled out is actually able to handle this new version of a message. Maybe you want the message to go to a different version of that app. Maybe it wasn't a problem with the message processing. You know, maybe it was a problem publishing to a downstream database, right? A lot of consumers take messages off Solace, batch them up, and stick them into a database. That's a very common kind of offloading use case, off-ramp. And, you know, if the database connection is down, you know, for that particular consumer, well, database publisher, but, you know, Solace consumer, maybe I don't want to move those messages to an error handling queue right away. And maybe I just want someone else to try it. So putting the messages back on the queue, you know, doing a NACK on Solace, putting the messages back on the queue allows another one to take another crack at it. So anyway, I agree. Yes, it would be there. General questions on guaranteed message handling. Gosh, in any distributed system, it gets rather complicated with ACKs and NACKs. But that is, we go into details with this. Obviously, with our Solace training, we have dedicated trainers, and they kind of, work with customers, and they go through all the APIs and all that stuff. But it would be obviously good to have this easier to find. It must be in the docs somewhere. I mean, this kind of behaviors on publish handling. So retransmission with redelivery is definitely one making use of. Yeah, so 5 redelivers. And then what, you move it to a dead message queue? So the dead message queue is great because it, it's ideal because it blocks, it allows you to not have a poison message at the front of your queue kind of holding up the whole works, right? So if something's wrong, you can't process that one message after 5 times or whatever. You can just move it off and put it into dead message queue. The dead message queue can actually be used for other cool stuff, like you can mix and match. So besides the number of redeliveries, there's also a TTL, right? You can set a TTL, time to live, an expiry time on the message itself as a publisher, 30 seconds or 10 minutes or whatever. But you can also set a TTL on the queue. Every queue can have a kind of a max TTL. Very useful in development when developers are just publishing to queues and forgetting to consume the messages. It kind of automatically clears down your queues. But you can also have in production, if a message is sitting on a queue for too long, it's stale, something went wrong, maybe the consumer is not able to publish it. If it's a time-sensitive message, obviously if it's sitting there for more than like a minute, that there's no point in replying back to the publisher, for example, because it's old. So you can set up a TTL with a DM queue. So if any message is older than a minute, it goes to the DM queue, and you can log it, do error handling and whatever off that DM queue. But you can also do delayed delivery using that particular pattern. So if you want to do something where you have a, so this is kind of it's a bit of a pattern, and they kind of stuck it in a weird spot in the docs. Oh no, we're in AMQP. That's not what I want. Is this what I want? It kind of explains the pattern around how to configure. Yeah, you configure a queue with TTL, max TTL, say like 30 seconds, and then you have no consumer on that queue. You set up the DM queue for that queue. So so call it QB. At the end of that 30 seconds, the message will then get flushed into the second queue, DM queue, B there, and that's where you have your consumer. So essentially, you're having the broker essentially buffer that message for 30 seconds. So that can be kind of useful. Bit of a, it's not a workaround. It's just combining features into one kind of. Anyway, I haven't configured a DMQ handler yet. It's just dropping it. Yeah. The client drops 5 messages, desubscribe them. Yeah. I mean, obviously, I would guess in production, you probably want to at least log, messages that you're throwing away, especially if you're using persistence, publishing with guaranteed messaging, which means they're going to a queue. Anything in Solace where you're publishing to a queue means it's actually a persistent message, right? Even if your publisher is using direct delivery mode, because Solace uses queues specifically for persistence. So if the message is on the queue, that means it's been persisted. If you're throwing it away, generally you want to log it, just at least to say, hey, something went wrong. This message didn't get processed, and maybe you can do some troubleshooting later. Then, not desubscribe, just disconnect it. Yeah. The wrapper code around the Solace broker. All right, so a lot of our customers use kind of wrappers to kind of insulate against sometimes it's to provide support for multiple brokers, right? So do you have other event brokers in your arsenal? Like, do you have something for Active or Rabbit or Kafka? I mean, are you trying to make a generic kind of wrapper? That'd be pretty cool. We've had other customers do that. I mean, even that's what JMS kind of does for the Java world, right? You can have this kind of messaging standard API specification, and you just change out the jars, and now you can talk to different brokers, right, using the same code, more or less, as long as you stick to kind of vanilla JMS there. Separation of interface for implementation. Yeah, fair enough. One advantage of using the Solace APIs directly is you have full access to every feature, right? But that can also get developers into trouble. Sometimes it's better to be, given a slightly simpler interface and setup, right? Yeah, picking useful defaults. Yeah, Solace's DNA, I guess, comes from very low latency, hardware-based appliance. We only had the software appliance, the software broker for the last about 5 years. It's built, financial trading platforms and that kind of stuff, and where every developer wants to get down to the nitty-gritty. And for 99% of kind of modern use cases, you don't need that level of stuff. So yeah, I'm not surprised that it's just, it's a lot easier to just kind of hide some of that and pick some regular defaults and give people a simplified interface for sure. Yeah. All right, cool. What was I talking about? I would like to read through. Give me a second. I'm just going to read through this. I'm going to try and skim it quickly. Anybody that's just joining, hi, I'm Aaron from Solace, by the way. We're just going through some Q&A on the Solace community. This is my weekly office hours here from noon till 1 p.m. every Tuesday, Singapore time, where we do Q&A about Solace. Sometimes I do a presentation. Sometimes I write some code. Sometimes I work on some PowerPoint that I need to do for the next day. Today we're going through some questions from a user who's actually online right now. So just come say hi. Come join us on the chat. Yeah, ACKs and NACKs always come back in order. So when I first started coding with the Java API, I actually didn't use the correlation key at all. I basically kept literally a linked list of published persistent messages that went out, and then as the ACKs and NACKs came back, I just trimmed them off the head, and it was always in order. That's just the way it is. Now, the one issue that you might run into with that, is if you have multiple publishing threads. They all go out the same session, so you kind of have a multiplexing type effect, but it's kind of weird. Multi-threaded publishers can be a little bit, I don't know, not dangerous, but just you have to be a little bit smart about them. So that's why, using the correlation key is the easier way to do it. So if you have a single-threaded publisher, it will always be in the same order, definitely. Reordering problem if retransmissions are NACKed. Yeah. So if you're publishing a boatload of messages, you're using streaming, you have an AD window, right? So like there are windowed persistent messaging protocol, and the ACKs are coming back asynchronously, and one message in the middle of that stream gets NACKed. Everything that comes behind it, say there was a really big message that got NACKed, everything that comes behind it might make it onto that queue or whatever. Now you might have a bit of problem. So as of today, there's no way other than changing the window size of the publisher to be 1, which essentially means you only have one message in flight between the API and the broker, to guarantee that if you get a NACK, you catch that NACK before the next message goes out. Typically, it's just a lot easier, especially for performance trade-offs, to just deal with that on the consumer side. That if there's a gap. It's not so much detecting a gap, right? Because if you're detecting a gap, that means that every consumer needs to be receiving the full feed from the publisher. So if your publisher is publishing, on a number of different topics, and your subscribers are only getting a subset of those topics, then there's obviously going to be gaps anyway, because unless each topic has its own message sequence number, which some people do, we've built feed handlers for finance companies that literally each individual instrument will have its own sequence number that's put in there by the Solace publisher, by the feed handler, essentially, so that consumers can actually see when there's a gap on a particular topic. So you could do it that way. But if you, it might not detect a gap. However, it would definitely detect when an older message comes in kind of afterwards, right? At least you know that just the way that AD windows work, if your AD window is, say, 10 messages big, that at most you can have 10 messages kind of out of order, or kind of because you'll get the knack, at which point you can stop your publisher and then kind of reattempt delivery. So yeah, something to keep in mind. If you just want to keep it simple, super ultra simple, and guarantee that you never have any ordering, you make your AD window size 1, right? It's a session property, pub, I think it's called pub AD window. Set that to 1, then you have definitely guaranteed you'll never have out of order. Your volume's not high. Yeah, and that, honestly, so if you're familiar with JMS, right? I know you're a C# guy, but in JMS 1.1, there is persistent and non-persistent. Now in Solace, non-persistent kind of has a bit of various meaning depending on the use case, but persistent is our guaranteed messaging. And in JMS 1.1, there is no concept of streaming persistent publish. There is in JMS 2.0, the new spec, but in JMS 1.1, everything was a blocking publish. When you called send on a persistent message, the API would block until the send call would succeed, which means ACK, or you'd throw an exception, a JMS exception out of that send call, and that was essentially the knack. Where was I going with this? Yeah, so it's similar to setting the AD window size to 1. If you're on a LAN, if you're on a fairly high-speed LAN, you can still get 2,000 easily messages a second out of that. 1 kilobyte messages. Obviously, the longer the network latency to the broker, the worse your performance is going to be, because you're entirely bounded by the round trip time at that point, right? So if it's 1 millisecond to the broker, then your maximum throughput is going to be 1,000 messages a second. And if you're publishing from on-prem into the cloud, and you're talking about 10 milliseconds or something, then yeah, it's going to be much slower. So something to keep in mind. Actually, I had a question that I hadn't asked on the forum. Oh, all right. Or couldn't find on the docs or other forum questions. Definitely multi-threaded publisher in our case. Okay, that's fine. Handle the responses back to the correct publisher without having to deal with the threading. Yeah, good. So multi-threaded publishers, I mean, obviously a simple way to do that is each publishing thread gets its own session, but now you're kind of burning extra TCP, connections to the broker for each thread. That might be overkill. But if you're using an AD window size of 1, maybe that's actually a good thing. If you have a multi-threaded publisher and your AD window is set to 1, you're now going to essentially get thread blocking or locking, right? Because if you publish a message while it's on the wire, until the ACK comes back from the broker, the API will not accept, or I think the send call will not process if you're using kind of blocking sends until the API can accept the next message. So yeah, if you have multi-threaded publishers and you're using AD window size of 1, your performance might not be that great. So I might suggest looking into maybe having multiple sessions, a session per thread, in which case you can parallelize to some degree. And if you're having multiple threads, obviously, you have a bit of a race condition between each thread anyway. So ordering, because of context switching and whatnot, even if your threads, that you called send on one thread just before you called send on another thread, who knows, right? Internally within a CPU architecture, it's always possible that one gets context switched away and the second send gets completed first. Who knows? So that's always a bit of a tricky thing there. Handle responsibility. Basically, each publisher. It's very C# specific though. Okay, that's cool. I don't know how good our C# samples are. Are they any good? I don't think they've been updated in a while. That's something that I'm supposed to be working on this year. 1 thread per topic. So is order. Oh, okay. Yeah, that's good. How many threads do you have? 1 thread per topic. When I'm doing some of my IoT type use cases, I have the samples are light on detail. Okay, well, I mean, as long as it gets you started, right, and pointed in the right direction. Yeah, some of my IoT demo topics, I basically, every message is on a completely different topic, right? I put the latitude, longitude in there. So every single message is a completely different topic. So yeah, that wouldn't work too well. But in this case, you could make every individual bus or individual car its own thread, I guess, if you want to guarantee completion. Anyway, let me finish reading here. We definitely want a window size greater than 1, multiple publishers, but each publisher pipe is relatively slow to transmit, so 30-ish topics being published at the same time. This is getting into the other question about using a task completion source as correlation key. Yeah, okay. I haven't, is that a question online, the task completion source as correlation key? I haven't seen that yet. Or maybe it's on here and I haven't got to reading it yet. We got to get a C# person on here that knows the API. When I first got hired at Solace, they hired me as a Java guy and this other guy as a C# guy. And we kind of split our knowledge, so I didn't actually have to ever learn C#. So you should get him on here. That's why I'm using data flows. Yeah, okay. Basically a table. Yeah, okay. And so yeah, so each message is like a row of the table, right? Your update is just updating a row of the table. Task asynchronous pattern. Yeah, that's going to be that's pretty detailed C# stuff that I'm not going to be able to talk to. I can talk to the Solace general stuff, but yeah, talking specific is going to be a little bit trickier. Okay, let me keep reading this. It's cold. Ugh. Add retry with backup case and rejected message events. So, one thing about, rejected message error events, right? So, when I started at Solace, I was in the professional services side. I was doing, consultancy. And a lot of it was working embedded with customers, working with their L1, L2 support teams on monitoring and kind of, frontline defense troubleshooting. If your application gets into a situation where a queue is full, there's been a number of failings that have happened to get to that point, right? So coding your application to properly handle queue full events and NACKs is important, but it's also important to highlight kind of other things that should be done in your Solace deployment to help avoid these situations, right? Things like proper queue sizing, number one. Customers ask, how big should I make my queues? And how much disk should I give to it? How big should my message spool be? And this comes down to a function of how many messages per second are you sending? How big are each message? On average, it's good to consider the peak burstiness, but for generally queue sizing, you're considering the average message rate and size. And then how long is the outage for? Typically, the reason a queue fills up is because a consumer that is draining that queue has crashed or something's gone wrong, and that consumer is stuck. And so that queue is now buffering data for your publisher for that consumer that's offline. And so, how big to make a queue? How long does it take you to get your consumer fixed? Can it be? Is it guaranteed? Is the SLA like 1 hour? Guaranteed, or is it maybe like 8 hours or 24 hours? How long until you can promise that consumer will be back up and online and able to drain that queue out? If it's 24 hours, you have to survive an entire day. You got to do the math and figure out what's the worst case scenario in terms of how many messages could my queue have to take in. Obviously, if you're building a queue that's more kind of request reply, it can be much smaller. But if you're feeding into a database, I'd rather have have the broker have a big enough queue that you can buffer all of that inside the Solace broker, inside the queue, to not allow your publishers to block, because that's what happens when your queues fill up, is your publishers get nacked, which means they're blocked, right? And ideally, you can have your database in the back end, disconnect, go away. The queue buffers messages temporarily, And then when the database comes back online, your consumers reconnect and everything gets publishing back in there. So make your queues big enough based on how long your outage could be and the message rates. Other things that are really important are things like setting the correct event thresholds. So not events in terms of Solace messaging, I'm talking about monitoring events. So Solace uses syslog, right? Excuse me if you already know all this stuff, but just to let me quickly pull up a broker here, and apologies if this makes my video get all jittery here. I'm gonna have to log out and log in with my other account. Just quickly switching up here. Log in. So this is the Solace Cloud. Free to sign up, give it a try. If it's great for hobbying at home. I want to make a little MQTT connected homes thing. Do some pub sub at home. I use this for all my demos now, so I don't have to run a broker in the lab. So just going into the PubSub Plus GUI here, the PubSub Plus manager. Right, so in our queues, right, when you create a queue, go into settings, look at the advanced settings. Right here, the alert thresholds. So you set your quota for the queue. By default in the software broker, it's 1,500. That's pretty big. Maybe that's not big. Maybe if you're feeding a database that has, it could be gigabytes big. But the alert thresholds, the default ones are terrible. In Solace, all of the alerts that are generated by syslog, right? So if you have a syslog forwarder set up, for things like the number of connections, the number of subscriptions, the number of transactions, all that kind of stuff, 80% as the high threshold, when it crosses 80% seems reasonable, If your application usually runs at 50 or 60 connections, you might want to configure your broker to have 100 connections and set the alert limit at 80. That seems kind of reasonable. But with queues are different, right? Because queues, when everything's running properly, your queues should actually be pretty much empty, right? Your consumer is draining the queue as fast as you're publishing into it, if everything's kind of running nicely. So if your queue starts to fill up, that is generally an indication that something's going wrong. And I would much rather not wait till 80% for that alert threshold to be triggered, right? That syslog event to say, hey, queue number 1 here is filling up. So in any production and or QA environment, dev, who cares? But I would consider putting these down to 25 or 30. Because waiting until you get to 80% for that queue high threshold means you only have 20% left, for your ops team to say, hey, I got this alert. I now need to go and kind of try and get the application team to fix this consumer. I'd much rather get the alert sooner than later. So that's one thing. So queue threshold alerts, make sure you have syslog forwarding configured. If you have the Solace, the software broker on-prem, there's docs for that. Check that out. For the Solace Cloud stuff, it's a little bit more complicated. You have to talk to our Solace Cloud people. But proper sizing, proper alerting, those are the two main ones to help avoid queues getting full. So that was a bit of a rant there. All right. Wow, so much text here. Customer orders, task completion, Change in data capture, Do you do your own change data capture, or do you have like a kind of a plugin for that? We've worked with a bunch of other companies that do change data capture, and then they event stuff onto Solace, usually using standard JMS. Even Oracle Golden Gate way back in the day, that was kind of essentially the granddaddy of change data capture that I'm aware of anyway. The unasked one is more of a general one. Might be useful generally, worth putting as a short YouTube video for other devs. What is the best way to apply back pressure to the broker if a subscriber is having trouble keeping up? You can set the max unacked messages. Is that the best way to do it? So max unacked messages, that is more how many, it's a little bit, max unacked is kind of used for flow control. Okay, so in terms of between the queue and the consumer, right? So let's not talk about back pressuring the publisher yet. So between the queue and the consumer, there are a couple of knobs that you can tune in terms of how many messages are going to be sent to that consumer. One of them is used for flow control, and that's again the 80 window size, but this time on the subscriber side. So there's the sub 80 window size. And this is like how many messages can be in flight between the broker and the API. So it's not how many messages can be outstanding, it's how many messages can be in flight. So if you set that to 1 and you're publishing over the WAN, then the rate that your consumer is going to receive messages is quite slow because only 1 message can be in flight at a time. So typically that's set with a kind of a window. I think the default is, God, I don't know, 50 or 100 or something. Anyway, the API will actually do an automatic transport ACK to kind of keep that flow going. Then there's the max unacked per flow, and that is essentially like how many unacknowledged messages can I send to a particular consumer? Because each consumer that binds to a queue gets its own flow, right? So if you're doing a non-exclusive queue, for round robin load balance delivery, each consumer has its flow, and the number of unacknowledged messages on each flow is counted individually. That is used to essentially, you can kind of do a bit of a prefetch, right? The API will kind of like fetch things off the queue up to that limit as it passes it up to the application space. Now, if you're, each time when you receive a message, if you're processing it right away and you're acking it almost right away, your max and unacked per flow can be quite low. Which means that if there's a problem in the application and something goes haywire, having that number set to be quite low means that, if the app crashes, it's not having to do redeliveries to another application, of thousands, tens of thousands of messages. But the default is 10,000. And that's more useful if you're doing kind of big batch-oriented processing on the consumer side. So if your consumer is writing into a database, typically writing individual messages one by one is not very efficient from a database perspective. So typically these consumers would receive 1,000, 5,000, 10,000 messages from the queue, and then do a one big kind of commit transaction to the database, and then acknowledge all those messages. You want to have the max unacked set to whatever that transaction size is there. So that's a little bit on the consumer side, right? So you can tune that. The default is 10,000, which is, some people might say is quite a lot of outstanding messages. In the old days, when I joined Solace, that used to be, so you can see I've actually set it to 100,000 on this queue. It used to be 250,000. This was the default, 250,000. So we actually ran into problems where when I was at a customer, they had one thread pulling data off the queue, putting it into like an internal data structure, and then another thread that was supposed to be processing it and acking it. And that second process had died. So no messages were being processed or acked, and the first thread was just pulling stuff off the queue, and it pulled down 250,000 messages before it blocked. And when they had to restart this consumer, all of those messages had to get redelivered again. So a lot of wasted bandwidth and CPU and all that stuff. So you want to kind of tune this basically as small as you need, right? Like if you're processing messages quite quickly, you can tune that probably a little bit less than 10,000. Anyway, that's all on the consumer side. In terms of publisher pushback, so obviously the big hammer is getting a NACK from the queue, right? Your queue bounces off the limit, you get a NACK for that particular message saying it can't be delivered to a particular queue. Now, I haven't talked about best practices around, typically in Solace, we don't recommend publishing directly to queues. We like to say be event-driven, use topics, publish on topics that your queues are subscribed to. So I don't know if you're using that, but hopefully you are. That it definitely allows for better flexibility in your future architecture. The messages will still be persisted the same way, but you have your queues subscribed to topics. And this way, if you want to have 2 or 3 queues receive the same message, your publishers don't have to change, right? They publish on their topic with the delivery mode of persistent, and the message will go into the queue because of these subscriptions that you have here. Yeah, bouncing, getting a NACK, that's kind of the big hammer. That'll definitely back pressure. There are lots of examples I have at customers where they've written either monitoring. They have the publishers able to listen to queue depths. You can do things like, these syslog. Here's an interesting one. So check this out. These alert thresholds. These not only can event over the syslog, right? So sending a syslog event, these can actually generate messages on the message bus using a special logging topic. I think it's inside the message VPN configuration. So if you want to play around with that. Advanced settings in the VPN configuration. Down here, publish message VPN events and client events. So message VPN events are things like, your number of subscriptions is getting high, your number of connections is getting high. Client events, I think maybe queues fall under this as well. But when a queue gets high and it issues that syslog kind of high threshold event, it will actually send it as a message on the message bus as well. So your data applications can actually listen to it. That's one way to do it. You can have your subscribers sending kind of periodic health check messages on topics, right? So using Solace not just for your state transfer, but also for kind of heartbeats, health information, statistics. It's often, if you have kind of easy ways to monitor what your applications are doing, have every 10 seconds your apps, whether they're publishers or subscribers or both, kind of publish their internal stats on a special topic, a monitoring topic, right? A monitoring topic that you can then, the publishers could listen to kind of make sure that their subscribers are keeping up. It's a bit of tight coupling, publish, subscribe. You generally want this kind of decoupled architecture, but it's easy to write kind of monitoring dashboards or kind of health check tables that are listening to kind of these heartbeat messages from everybody. In the Java world, we have JMX, where you can kind of introspect Java runtime processes. But when you have everybody's connected with messaging, everybody is connected and online with Solace subscriptions and topics and everything. They can just publish these stats back onto the broker, and you can just write a little subscriber that listens to them, whether it's the publishers that want to listen or a monitoring application or whatever. So that is some long rambling on how to push back on. Acknowledge this is the best way to do it. Block the receive in the flow. Block on the receive in the flow. Okay, this is on the consumer side, right? So the C and C# APIs, they don't have multiple threads internally like the Java API does. The Java API, there's two threads that one reads from the socket, and then there's another thread that actually dispatches up to the application space. But in the C and C# APIs, it's all done with one thread, right? The reactor, the context thread. And so this is a really big reason as to why you don't want to actually do processing in the callback. If you're doing anything more complicated than just writing it to the console or something, you want to take that message from the callback and put it into some kind of internal application data structure and have your worker threads, have back-end worker threads kind of doing the processing of that. More like the reactor pattern, right? If you're familiar with that, you want to keep the reactor pattern, the thread that's reading stuff off the socket and dispatching to your application nice and tight, nice and fast, and don't do any processing in the callback on the receive side if it's going to be slow at all, because you don't want that thread to block up. There's other stuff that runs on that thread, right? API timers and all sorts of other stuff. So if you block up that thread, you're kind of in trouble. There is, if your subscribers need to slow down, like if internally you're running out of RAM or something on the consumer side, there is flow start and flow stop, right? So you can kind of turn the messages on and off the consumer, pulling data off the queue using some API calls. So that might be something, but that's still not pushed back to the publisher. The pushback to the publisher. Ideally, things are sized correctly, right? Again, this comes down to sizing. It's like, your publishers, you should know what the max publish rate is, max sustained, the peak, the burst, and know what your consumer's performance is. And if there's a mismatch there, how long is that mismatch going to last for? Make sure that your queues are big enough to be able to deal with that, and all sorts of sizing. But yeah, monitoring the depth of the queue is one way to do it. Having the publishers kind of listen to these queue high events is another way that's been done. Obviously, if you're waiting for, if If you set your queue thresholds to be quite low, like 30%, maybe you don't want your publishers to be quite stopping that at that point. So maybe using, we have a management API called SEMP that you can actually monitor the queues with. That's something else to maybe check into. Anyway, there's a lot of options. All right, anyway, blah, blah, blah. What you should do instead. It would be nice if the subscriber could say, hey, I can't ingest this right now. Stop sending me the data for a few seconds. Yeah, so that's kind of like an application to application type of signaling, right? That is outside of, that's your subscriber app wanting to tell your publisher app something. So it's not something that's handled directly in the Solace API protocol space, but you can easily do that with a direct message. You know, the subscriber just publishes periodically a status update, or something that says, hey, I'm congested, or hey, I'm backing up, or hey, my database is down and I'm now buffering things internally and I'm disabling my my flow temporarily, so messages are going to build up in the queue. Hopefully your queue is not going to fill up to the point where you're blocking your publishers, right? The whole idea of having this kind of, well, one of the main ideas of having a message broker and a queue sitting in between your publishers and subscribers is that decoupled thing where your publishers, don't have to block. But if you do need to slow them down, yeah, I would use some kind of direct message signaling on some kind of health monitoring topic. That could be a pretty cool way of doing that. Central alert threshold is good. Yeah, I know. I should make. I got. You know how long it takes to make a two-minute YouTube video? it's literally like a day. SQL Server CDC. Is it your own or is it something open source? I'm wondering, and I'm just wondering if it's you're using something off the shelf or not. The max and max per flow is the one I'm referring to. Yeah. So you have a subscriber with a receive buffer and processing pipeline. Right. So the max unact per messages per flow. So this is essentially, yeah. So the max unact is you're pulling stuff off the queue, but you're not acking it for whatever reason. If your downstream database is offline or slow or something, eventually the queue will kind of throttle itself. That's exactly what it is. So it's essentially saying if you get to 1,000 messages outstanding and you haven't acted them, now pause this flow. And there's, for the getting into even more depth with monitoring, there are actually stats that you can look at on each queue that show you every single flow and what state it's in. So you can actually tell. I don't have any consumers right now connected. Let's make one. Let's make a new window. I'm just going to show you SDK perf. If you don't know what it is, it's the greatest command line test tool for Solace that's ever existed. There are SDK perf instances for Java and C and .NET, and it basically allows you, watch -H, basically all the options. Basically, you specify a username, host, number of messages you want to send, how big the messages are, the rate, which topics you're publishing on, which queues are you subscribing to, and you can basically do all this testing here on the command line. So I'm just going to connect to my cloud instance, and I'm going to subscribe to Q1 just to take a look at it. No, not allowed. What? Seriously? No time. What time is it? Oh my God, it's after 1. All right, so tell you what, I'm just going to finish up here. Anyway, there are ways to check if a flow has been paused by looking at its stats. If you check out SEMP, SEMP for queues, you'll see various egress flow information, and you can actually check to see if a flow has been congested. That's useful for, that's pretty advanced level monitoring, to try and check if a consumer is having problems. But anyway, let me carry on here. It'd be better to just do the same at runtime rather than close out. Yeah, that sounds about right. No need to push back to the publisher. Yeah. push back to the broker. Yeah, exactly. I mean, if you want to slow down the publisher, yeah, that's what you can do. You can signal him with a direct message. That's great. But it's just in terms of, yeah, you're running out of RAM inside your consumer. You're running out of processing capabilities, whatever. Setting the max enact kind of just has the broker throttle that for you. But you can always control it with flow start stop as well. So. Yeah, exactly. Publish multi-subscribe model. So you don't want to. Okay, perfect. So I'm very much assuming that you're publishing on topics then and having multiple queues subscribe to those topics, right? So you're doing kind of one-to-many style of distribution. One thing that's cool about Solace is that it's all passed by reference, right? So even if you're publishing a persistent message and on a topic and that topic lands, that message lands on 5 different queues, it's only written to the disk once. So regardless of your fan out, even if it's 1 to 10, it's only written into the disk once rather than once per queue like some of our competitors do. So I've gone past my hour. Yeah. SQL Server has CDC as a built-in feature. Oh, okay, I didn't know that. I'm not an SQL person, but that's good to know. I'll have to check that out. We have a bunch of partners who do CDC, and like Solace doesn't build a lot of the integration tooling around it, but we have partners for that, and a lot of obviously open source exists. Things like Logstash and Splunk have JMS listeners to pull data off Solace and all sorts of stuff. Anyway, using top-to-queue mapping feature, very nice feature. Yes, that is like the fundamental, quintessential Solace persistent messaging, guaranteed messaging architecture is publish on topics using persistent delivery mode and consume on queues and have all that mapping controlled within the broker, right? And it allows you to add multiple consumers. I need that data to go to somewhere else. You make a new queue, you add that subscription, and the data just, you get a copy for free for that new consumer without having to change your publisher or your original actors, completely unchanged. That code could be 5 years old, and you can get a copy of that data for free without having to touch anything. Just do a little broker configuration, right? So anyway, that was a pretty good session. I hope that we covered some stuff. Good questions. Thanks for joining. I'll see you on the community, I'm sure. And thanks to everybody for watching. I hope this was useful, and see you next week. Same time, noon Singapore time, on Tuesdays. All right. All right, and you're welcome. Good stuff. I'll fire you I'll stick it on YouTube, and I'll fire you the link in case you want to watch it again later. It'll be saved on Twitch for 2 weeks. So anyway, thanks everybody. Thanks, Almiron. See you later.